All right, we'll look at our Chapter 7 review as we going back through this chapter. Let's go back to what we did at the beginning. As we started to introduce identities, we looked at simplifying some trig expressions. And doing that, a lot of algebra review, distributing, factoring, working with fractions, and then, of course, applying our identities to simplify things. Now we have our basic identities, the quotient identities, the reciprocal identities, even odd definitions. We also had, of course, Pythagorean, sum difference, double angle, and half angle identities. So if you need to refer to those, you can. Let's go ahead and look at problem number 1. We've got two examples, 1A and 1B. In 1, it says to multiply and simplify. So let's go ahead and take care of the multiplication, right? We've got secant, right, that we need to distribute. So let's go ahead and multiply that through. So as we do that, we have the secant of x times the cotangent of x plus the secant of x times sine of x. So distributing secant through. And now let's apply identities. All right, let's rewrite. I'll write it here on the side. Let's rewrite everything in terms of sine and cosine. So remember your identities. So we're going to use our reciprocal identities, right? And our quotient identities. So let's write those down. All right, so secant, and we can write it right here beneath it. We know secant is equal to 1 divided by cosine x, using the quotient identity, times cotangent. Now cotangent is equal to cosine over sine, using the quotient identity, tangent sine over cosine, plus secant, which again is 1 over cosine, right, times sine of x, right? So again, that's applying our identities. So again, quotient identities and the reciprocal identities. So right there in the reciprocal, and then there's an example using the quotient identities. With that said, what happens next? So now we look to divide out common factors. So let's go ahead and divide out cosines, right? They cancel out, right? I'll make a note. Divide out common factors. All right, and as we do that, what does it simplify to? So we have 1 over sine x plus, now we got sine times 1 over cosine, which will be sine x over cosine x. And now we're ready to apply our identities again. All right. So let's apply the reciprocal and quotient identities. So with this one we have 1 over sine. Well, 1 over sine, we know sine is reciprocal with cosecant. It's cosecant x. Plus, we know sine over cosine is definition of tangent of x. So in the end, it simplifies down to cosecant plus tangent. Cosecant x plus tangent of x. All right, so there it is in simplest form. So we multiplied and we simplified. Now again, we use the reciprocal identity on this, and we use the quotient identity, right? So make note of those. All right, so let's move on. Now in our next example, in B, same thing, we got to multiply and simplify. So we have sine here of theta to distribute through. So let's go ahead and multiply sine theta through. Now there are three different terms to distribute through. So again, we're going to go ahead and distribute, just like we did in our last example. The distributive property will be our first step. And as we do that, we have sine times secant theta, tan theta, plus, so there's the sine multiplied with the first term, plus sine theta times cosecant theta, there's sine distributed with the second term, plus sine times cotangent theta. So we distribute through to both terms. And now let's apply our identities. Let's rewrite everything in terms of sine and cosine. So again, that'll be our second step. Rewrite as sine and cosine. So again, use your identities. Use identities. All right, use reciprocal, right, and quotient. And as we do that, what do we have? So this is equal to the sine of theta times secant of theta, which secant of theta, and write it right here beneath, is reciprocal with cosine. So that's 1 over cosine theta. And then tan of theta, we know tan is identity with quotient identity is sine divided by cosine. So we go ahead and rewrite it. So again, rewriting these. And then we have sine times cosecant. So what about cosecant theta? Well, cosecant theta, cosecant's reciprocal with sine. So it's 1 over sine theta. So rewrite it. Plus, now we have sine theta times cotan theta. And cotan, of course, using the quotient identity, is cosine over sine, right? Which is the reciprocal of tangent, which was sine or cosine, which we did earlier. And now we look for what? All right, multiply, divide out common factors. Let's go ahead and take care of that. So we need to go ahead and multiply here. So we have sine, right, times 1 times sine. So I'm going to go ahead and multiply here. So we multiply these together. This is going to be equal to, let's go ahead and write that down here in the first step. This will equal sine theta, right, times 1 times sine. So we multiply all the numerators together, divided by cosine times cosine. And then here in the middle, right, we have a common factor. Sines divide out. So that leaves me with a plus 1. All right, and then here we also have a common factor of sine theta. They divide out, so that leaves me with just cosine theta. And then as we simplify down, of course, sine times sine is sine squared theta. Cosine times cosine is cosine squared theta, plus 1 plus cosine theta. Now, sine squared over cosine squared, what does that equal to? All right, that's equal to tan squared theta plus 1 plus cosine theta. All right, so again, using the quotient identity. So again, I'll make that note here on the side. Quotient identity. Tangent equals sine or cosine. So tan squared is sine squared over cosine squared. Now, here's where the trick is. Don't stop there. Hopefully you recognize Pythagorean. Here's the Pythagorean identity. I'll write it over here on the side. And if you need to get your identity sheet out, you can. But Pythagorean identity, all right, sine squared plus cosine squared equal 1. If you are to divide both sides by cosine squared, you will get this. 1 plus tan squared theta equal to secant squared theta. So that equals secant squared. So 1 plus tan squared equals secant squared. So we'll go ahead and replace that. So using the Pythagorean identity, it simplifies these two terms into one function being secant. So we have secant squared theta plus cosine theta. And there it is in simplest form. So we multiply and we simplify. All right, let's move on. Let's go to problem number 2 instead of multiplying and simplifying. All right, in number 2, we're going to factor and simplify. So 2 examples, A and B. Now in A, I want to review, we got our difference of squares property. So we want to use that. So we'll write it here to the side. We need to difference of squares. All right, so what is the difference of squares? A squared minus B squared factors to A minus B times A plus B. So again, this problem, what we have is tan squared x being squared, right? That's the square, tan 4x, you square tan squared. Minus secant 4x, well that's secant squared x being squared. So there it is, there's your A and your B. So here's your A squared, so to speak. All right, and here's your B squared. So again, A minus B, A plus B. So as we factor, let's go ahead and do the factoring in the next step. So as we break that down, let's go ahead and factor it. So we factor down A minus B, that's tan squared x minus secant squared x. There's A minus B times A plus B, which is tan squared x plus secant squared x, right? As we go ahead and multiply that through. Now, as we're looking at this, all right, we've done our factoring. All right, what I want you to recognize in this example, right, tan squared minus secant squared. Here's where you have your Pythagorean identity, right? Or, if you want, we could rewrite everything in terms of tan squared at this point. So different ways to go. So we just mentioned earlier, let's apply the Pythagorean identity. So I'm going to try to simplify further. I factored. Now let's apply Pythagorean identity. And we just used it in our last example. We know that 1 plus tan squared x equals secant squared. So let's rewrite. So I'm going to rewrite everything in terms of tangent. All right? So let's do that. So rewrite, all right, in terms of tangent. As we do that, so back up here to our problem. So we have tan squared minus secant squared. Well, again, that's tan squared x minus, well, secant squared is 1 plus tan squared x. Right? That's secant squared. So using my identity, right, we were able to rewrite that in terms of tangent. And then we'll do the same thing on the next one. Let's go ahead and work with the next expression. So here we have tan squared x, and I'm going to rewrite secant squared. So secant squared again, so that's plus 1 plus tan squared x. As we simplify that, as we go here, so again, we've rewritten secant in terms of tangent. So now everything is written in terms of tangent. All right, now let's distribute the minus sign here, and notice what it simplifies to. So here we have tan squared x minus 1 minus tan squared x as we distribute. All right, times tan squared x. Well, what do we have over here? We have a couple of like terms. Let's just go ahead and add those up. So as we add up those two, term, we have 2 tan squared plus 1. And notice here we got like terms, so we can go ahead and combine these 2 tan squares. So it ends up being -1, which, yeah, tan squared minus secant squared is -1. Even if you were applying your identity by rearranging it earlier, you could. Times 2 tan squared x plus 1. As we distribute, we multiply the -1 through. Right, we get -2 tan squared x minus 1 as we look at it in simplest form. All right, so there's our simplified expression. All right, so again, using identities, combining some like terms, factoring, of course, at the beginning, difference of squares property from algebra. As I mentioned, a lot of algebra review in a lot of these problems. All right, let's move on. Let's go to problem number 6. So in number 6, what can we factor? So I'm looking at number 6. I've got a common factor of 6 in both terms. I've got a sine showing up in both terms. I've got a cosine in both terms. So again, we want to factor. All right, so we're going to do that by using our GCF, our greatest common factor, which in this example will be a 6 sine x cosine x. So this is equal to, as we factor out the 6 sine x cosine x, well, in our first term, what are we left with? We're taking out the 6 and the sine, and we're taking out a cosine and cosine cubed, so we're left with cosine squared x, right in that first term. And again, if you were to multiply or distribute back through, you're going to get back what you started with, which is 6 sine cosine cubed. Plus, as we take out the 6 in our second term and our sine, well, we had sine cubed, so we'll be left with sine squared, right? And we took out the cosine. So again, in parentheses, what left after factoring out the GCF? And here's our fundamental identity. We know exactly what that simplifies to. So this is our Pythagorean identity. We know that equals 1. So we can definitely simplify quickly. So this is equal to 6 sine x cosine x times 1. Right? So we've got 6 sine x cosine x. Now here's where I want you to look a little bit harder with identities. All right, and recognize an identity here. I want you to try to apply your double angle identity. All right? Apply double angle identity for sine. If you need to refer back to identities, you can, but I'm going to write it out here. Right? We all know the sine of 2x equals 2 sine x cosine x. So I want to rewrite that. All right? So over here, as you see 6 sine x cosine x, well, that's 3 times, right, 2 sine x cosine x. So I'm going to rewrite it. So 6, which is 3 times 2 sine x cosine x. And then here's my identity. All right? So that's equal to 3 times the sine of 2x. So in simplest form, we have 3 sine 2x for our expression. So that one simplified nicely, right, in 6b after factoring. All right, moving on, let's do some more simplifying. Let's simplify the following expressions. All right, in number 3, 3a, we've got a fraction. So with these fractions, we're looking for common factors, right, and divide them out. So for example, we've got the 7 and the 28. Well, 7 divides in 28 4 times. We have the cosine x, right? If you want, we can put it in a different color. We got the cosine x and the cosine cubed. So that divide a cosine out we have a cosine squared x, right? As we simplify it, cosine q divided by cosine is cosine squared. And then we have the sine x term, right? We have a sine x divided by 1. Sine squared divided by sine is sine x. So in the end, after we divided out common factors, and we'll make that note, divide out the common factors, we're left with what? We're left with a 4 times cosine squared x times 1 divided by what? Sine x times 1. So we have 4 cosine squared x over sine x. Well, apply an identity. So I want you to try to apply identity to that. Well, let's try to apply the quotient identity. All right, make that note. Apply quotient identity. All right, what do you recognize as far as quotient identity goes? Cosine over sine is cotangent. I'll write that here. Cotan x can be replaced with, again, cosine over sine, or vice versa. And that's what we have here. So this is equal to 4, and we can break it up. Cosine squared is cosine x times cosine x, all divided by sine x. And there's my identity. So right here is cosine divided by sine. All right, so that's equal to cotangent. So we can replace that. So we simplify down. This is equal to 4 cotan x. All right, yeah, cotan x equals cosine over sine times cosine. All right, so we end up with 4 cotan x cosine x in simplest form. And there it is simplified. So simplifying that quotient, that fraction. Let's do another one. Let's see if we can simplify here. All right, we'll go ahead and factor, right? So when I see this numerator, let's factor difference of squares. Right, so a squared minus b squared factors to a minus b times a plus b. Right, so if you look at cosine 4x minus sine 4x, right, that's cosine squared x minus sine squared x times cosine squared x plus sine squared x, using my difference of squares property. So again, I'll write it down here. A squared minus b squared equals a minus b times a plus b. So applying that property. So here's my a minus b times a plus b. So I'll write that above it. A minus b and a plus b. All right, so again, recognize these squares. So we had cosine squared x being squared, and we had sine squared x being squared. So a difference of squares. Now, as we did that, what happens? My denominator, which is cosine squared x minus sine squared x, is now a common factor. So as we divide out the common factor, right? So we divide those out. Right? Divide out common factor. All right, what are we left with? Just cosine squared x plus sine squared x, which is our Pythagorean identity. So what we have here in front of us, Pythagorean. So what does that equal? That equals 1, right? Cosine squared plus sine squared. So in the end, it simplifies to 1. Right? Simplifies quickly on that one. Moving on to 3C. Let's see if we can simplify this expression. Now, you recognize, hopefully, two basic identities here at the beginning, right? I want to look at the quotient identity, right? So I'll write that down here. Quotient identity, you're right, you see quotient identity for cotangent. And what do you recognize here on this one? 1 over sine squared, that's my reciprocal identity, right, for cosecant. So remember, cosecant is 1 over sine. All right, just like quotient identity, we know that cotangent is equal to cosine over sine. So as we apply those, so let's go ahead and write it right here beneath it. We got cosine over sine. Well, applying the identity, that's equal to cotangent of x. So replacing, right, cosine over sine, what it equals? It equals cotan x minus 1 over sine squared. Well, 1 over sine squared, we know 1 over sine is cosecant, so 1 over sine squared is cosecant squared x. So replacing it, we're using our reciprocal identity. So we've eliminated the fractions altogether. And remember, this is squared here, right? Cosine over sine squared, so that's cotan squared. So simplifying down, I have cotan squared x minus cosecant squared x. Now, I want you to represent that is an identity. And if you want to, you can apply your Pythagorean identity. So I'm going to go back to identities. I'll write it here on the side. Pythagorean identity, right? Sine squared plus cosine squared equal 1. If you were to divide both sides by sine squared, you would get 1 plus cotan squared. 1 plus cotan squared equals cosecant squared. All right, so I could apply my identity. So right here, when I see this, right, there's the Pythagorean identity. So apply it. So this is equal to cotan squared x minus, well, cosecant squared is the same thing as saying 1 plus cotan squared x. All right, and then we can distribute. Let's go ahead and distribute the minus sign through. As we distribute it through, what do we end up with? We end up with cotan squared x minus 1 minus cotan squared x. And then combining like terms, cotans eliminate, and we simplify down to negative 1. Right, as we simplify that. All right, let's do one more on this page. Let's go and finish this page out. Number 4. Let's rationalize the denominator. So let's do another simplifying process with a trig expression. So when you look at this root, we've got a square root of a fraction. So we have a numerator and denominator. So first thing we're going to do is go ahead and break it up into two square roots. Right, square root of the numerator, square root of 1 minus sine alpha, divided by the square root of the denominator, which is square root of 1 plus sine alpha. And now our directions say to rationalize the denominator. So we know to rationalize a square root, we have to eliminate the square root. So we have to create a square. So we're going to have to multiply both the denominator. To create a square, I've got to multiply with the same thing, square root of 1 plus sine alpha. We got to do the same thing, numerator, right? Whatever we do to the denominator, we must do to the numerator. We got to, again, create a fraction of 1. We can't change the problem. So that's 1 there, right? Square root of 1 plus sine alpha over square root of 1 plus sine alpha. So it simplifies to 1, so it doesn't change anything. But now what happens? So if you look at our denominator, right, as we multiply these together, what's square root of 1 plus sine alpha times square root of 1 plus sine alpha? 1 plus sine alpha. We created the square. So again, I created the square, which eliminates the square root. So I'm going to write that down. Now with that, how about the numerator? So in the numerator, we can go ahead and multiply these two. Right? We have 1 minus, we're going to combine these into 1 square root. 1 minus sine alpha times the 1 plus sine alpha. And then we can distribute. Right? So we'll go ahead and fold that out, multiply it through. All right, so let's take that down here to our next step. So that'll be equal to the square root as we distribute. So let's go ahead and fold that out. Let's go ahead and multiply. Got 1 times 1, 1 times sine alpha. So 1 times 1 is 1, 1 times sine alpha is sine alpha. And then I'll do the next one in blue. We got to multiply sine alpha through. Let's go ahead and multiply. Negative sine alpha times 1 is negative sine alpha. Negative sine alpha times sine alpha is sine squared alpha as we distribute. And all that's divided by 1 plus sine alpha. And then what happens in the numerator? Well, the sine alphas cancel out. All right, and we end up with the square root of 1 minus sine squared alpha divided by sine alpha. And here's our Pythagorean identity. So what do we have right here? Pythagorean. I'll write it right over here on the side. Pythag identity. Right, we know that sine squared theta, or so we'll go ahead and write it as alpha, since that's what they're giving us. Sine squared alpha plus cosine squared alpha equal 1. So if I were to solve for cosine squared, what would happen? Cosine squared alpha equal 1 minus sine squared alpha. So there it is. There's my identity, right, that I can go apply. So as we apply that, right, we'll go ahead and replace it. So this is equal to square root 1 minus sine squared. Well, that's the square root of cosine squared alpha. Right, all divided by the sine of alpha. And then we got a perfect square. What's the square root of cosine squared? That's cosine alpha over sine alpha. And we all know that cosine alpha, right? And where does sine alpha come from? I forgot my 1. Somebody correct me on that one. I forgot to write down the 1 plus sine alpha. I need to go ahead and add that. Denominator with 1 plus sine alpha. But now we've got it in simplest form. Right? So there it is. There's our rationalized denominator. No longer looking at a square root in the denominator. We created that square by multiplying the numerator and denominator by what we had in the denominator, right? Which is the square root of 1 plus sine alpha. And then we distributed. So again, we can make that note here above it. We need to distribute. Slash multiply here. I'll put that note above it. And then we simplified in the radical numerator, which we're able to use a Pythagorean identity. So we applied it. So applying the Pythagorean identity, we were able to simplify the square root of 1 minus sine squared down to cosine squared, which we know is a perfect square. So we were able to rationalize the numerator. All right? So we'll stop there. That's a good place to take a break, and we'll continue on with our review later.